At the end of this module, you will be able to represent motion graphically. Distance time graphs. When a body moves with uniform speed, it will travel equal distances in equal intervals of time. In other words, the distance traveled is directly proportional to time. Thus, for uniform speed, a graph of distance traveled against time will be straight line. Please note that we can also write the term uniform velocity in place of uniform speed in the graph. We can now see that the distance time graph for a body moving at uniform speed is always a straight line. The distance time graph of a body can be used to calculate the speed of a body. We know that speed is equal to distance by time. In figure, distance traveled is equal to OC, which is equal to AB. Time taken equals AB. Putting these values in the above relation, we get speed is equal to AB by OB. But AB by OB is known as slope of the graph line OA. Therefore, in a distance time graph for uniform speed, the speed of the body is given by the slope of the graph. We can have distance time graph of a body to find the value of speed of the body. The slope of a distance time graph indicates speed. If, however, the speed of a body is non-uniform, then the graph between distance traveled and time is a curved line. Speed time graph or velocity time graph, when the speed of the body remains constant. By saying that the speed of a body remains constant, we mean that the speed does not change with time and hence there is no acceleration. So, a speed time graph for a body moving with constant speed is a straight line to the time axis. If the speed time graph of a body is a straight line parallel to the time axis, then the speed of a body is constant. Since the speed of the body is constant or uniform, there is no acceleration and hence there is no question of finding the acceleration from such a speed time graph. We can, however, find the distance traveled by the body in a given time velocity graph. We know that speed is equal to distance by time. Distance is equal to speed into time. Now, to find the distance traveled by the body at a point C, we draw a perpendicular CB at point C, which meets the straight line graph at point B. Speed at C is equal to CB. Now, speed at C is equal to CB, but CB is equal to OA. Thus, speed at C is equal to OA, time at C equals OC. Now, putting these values of speed and time relation in one, we get distance traveled is equal to OA into OC. Distance traveled is equal to area of rectangle OABC. OA into OC means length into breadth. So for a rectangle, OA into OC or length into breadth is equal to its area. So in a speed time graph, the area enclosed by the speed time curve and the time axis gives us the distance traveled by the body. In this module, you have learned that the slope of the descent time graph gives speed and the area enclosed by the speed time curve and the time axis gives the distance traveled by the body.